As a project manager, I'm regularly looking at a schedule and a critical path to make sure that I can deliver the project on time. And if I can't deliver the project on time, I want to raise an alert as soon as possible to see what other mitigating things I can do to still deliver. One of those things that we can do is resource optimization. So in this video, we're going to take a look at some resource optimization techniques. So first of all, we have something called resource leveling. Let's say that we're an engineering organization, could be software engineering or really any kind of engineering, civil, mechanical, chemical, any kind of engineering. And there's one particularly tricky task that requires expertise. And there's one person in our organization who can do that. And every project we have requires this person, the subject matter expert. So that person can be, well, number one, that person's usually very valuable. But that person can oftentimes be a bottleneck or a constraint because there's only one of these subject matter experts to go around, and every project needs that person. So with resource leveling, what we can do is say, okay, this is when that person's available, or this is when whatever, could even be a piece of equipment. Maybe it's a crane or a bobcat or something like that. So this is when that's available. Let's adjust where we can to fit that schedule. If we can adjust using float, great. That's an easy solve. If we can't adjust using float, that gets a little more tricky because then we have to look at changing the schedule, the finish date of the project. But there again, better to know that sooner rather than later, so that if you're building a building and you have tenants moving in, you can let them know with plenty of time to prepare that there might be a delay in their move-in. Now, another option is resource smoothing. And this is where we look at adjusting the sequence of activities or when activities happen, hopefully within the float time we have available, to make better use of our resources. So what we don't want to do is have maybe a design engineer with 120 hours of work on week 3 of the month, but then 20 hours of work on week 1 and 0 hours of work on week 2 and 0 hours on week 4. So resource leveling says, okay, how can we reallocate this to make it more efficient? I believe this is a lot easier to visualize when we look at an animation. So here I have some kind of software I'm going to develop. And I have 3 engineers, Kaz Dolowitz, Pamela Rocky, and me, Brandon Jones, 1 quality engineer. Now, each item being developed requires 2 days of quality checks, so 2 days of quality engineering time. And then at the end of the project, we need a total of 5 days of regression. So we all start day 1. Kaz starts on task A, which takes 3 days to complete. As soon as task A is complete, we have the 2 days of QE for that, so Kaz passes that off to the QE lane and starts working on task D. Now, that's at the end of day 3. At the end of day 4, I finish up with task C. And guess what? I have my 2 days of QE, so I pass that up to the QE lane. And then at the end of day 5, Pamela has finished task B, and there are 2 days of QE there. Now, day 6, we have Kaz Dolowitz finishing up his second task, which is activity D, which is 3 days of effort. But also, guess what? It requires 2 days of QE. Now, you can probably visualize what's going to happen here because you see we had 3 developers and 1 QE. And these 2 days have come in very quickly. 2 days per task have come in very quickly. And if you know anybody who works in the quality area, they'll probably tell you this is a fairly common scenario. The developers work overtime to try to make a date, and all of a sudden quality gets backlogged with all of those tasks to test. And then quality is suddenly overworked. So let's see how this plays out in our animation. Okay, I see some overlap here. Quality is already working on A when C is ready, and then when quality can be working on C, B is ready, and then D becomes ready, so on and so forth. So let's level a bit. We go ahead and we pass C up into this lane. Quality starts on that after working on task A. Then we pass up B. Okay, well, we see that B is going to overlap with regression a bit already. We pass up D and we see, okay, there's even more overlap. So with resource leveling then, what we'll do is say, okay, well, let's do these in sequence and then let's delay regression until that's all complete, the consequence is it does indeed move our end date for the entire project. And once the developers are finished with their task, well, okay, they move on to another epic, they do something else, and quality is their testing. If quality finds a defect, they might send it back to the developer, but at this point, they're able to move on to a new task. So that's one option, resource leveling. Another option is schedule compression. As a project manager, these are great tools to have in your tool chest, but apply sparingly. In other words, don't start a project saying we're all going to work overtime, we're going to run these things in parallel, we're going to switch hats, all that stuff. These are good things to have in your back pocket when things do fall behind, which frankly does tend to happen fairly frequently on projects. So first of all, we can crash a project, which is add resources, approve overtime, and pay to expedite. That can increase risk and cost. Overtime actually used to be kind of a given that, all right, if you're falling behind, you're going to need to work extra hours to make it up. I will say in the days of Scrum, emphasis has gone off of overtime, and I'm happy for that because there's a reality that if you work 60 hours a week for an entire year, it's not 150% of a full-time employee. It really goes right back down to 100% because you lose efficiency when that's all you do and you don't have time to go out and take a walk and collect yourself. So overtime, we could throw it in, but we want to use it sparingly. Adding resources. This is a funny one because many times people say, well, adding resources to a project doesn't make it go faster, because you have to train those resources, or those resources might not have this knowledge that they need, and they need to get access to repositories and stuff like that. And so it gets frowned on a lot, but on the other hand, we tend to do it quite a bit. And many times there's simply not an alternative. If you have 4 people and you need 8 to do the job and get it complete, 4 people aren't going to double right away. But then also consider things like resignations and attrition. People leave teams all the time. People join teams all the time. So adding someone to a team and having that overhead of the learning curve and the like, that's something we simply deal with all the time. And so moving someone onto a team is not all that uncommon. Okay, so what do I recommend for my project manager friends then? What I recommend is work with your engineering manager counterparts on a really good onboarding process. So not just, here's your first day, here's your laptop, here's Shelly, who's our tech lead, go talk to Shelly for a little bit, I'll see you in 2 weeks. That's not real onboarding. Real onboarding would be things like actual training that's reinforced with some type of quiz or examination. If you're working with software, maybe a development environment that has the project already in it with breakpoints you can debug through. Maybe use a virtual machine. That was a really good trick when I was working in point of sale and we were serving a lot of different customers. It would take days and days and days to get your environment set up well. What I ended up doing, and in that company I was manager of technical training, so what I ended up doing was making some virtual machines for the customers I worked with the development environment and the database and everything already set up. So when someone started new, I could say, okay, load this virtual machine, start, do all your coding there, and you're ready to go. And that completely minimizes that startup time of what IDE should I use, what development environment, in other words, what database should I use, what are the passwords. Everything was already set up on that VM. Other things that will help onboarding is very clear definition of done and definition of ready, so that people know what's expected of them when they're going to commit their changes, and knows what's expected when they're going to start working on something. And then really just following open standards on things like the Scrum process. If you follow widely accepted standards and you hire someone who's experienced, chances are they have already had experience with that. So several things we can do to minimize the risk there, but nonetheless there's still going to be risk. Fast tracking in Scrum we'll take a look at in an animation in just a moment. So fast tracking is parallelize activities that can be done in sequence. So, my part-time job, I'm a part-time professor, which is where these videos come from, but full-time job, I'm an engineering manager over mobile apps, and have done that role for a little over 6 years at this point. And it's kind of funny, a conversation I see quite a bit when we're developing mobile applications. We'll go into an annual planning and say, okay, well, before we can start on the user experience, all of the services, in other words, all the APIs must be complete. Okay, and I said, well, that's great, because then we're dealing with a known quantity, and there we go. But in the back of my head, I think, I've read this book before, I know how it ends. We all smile, we all agree to that. 2 months later, I get a note that, well, the server side or the APIs are running a little bit behind. But we still need to keep the whole project on schedule. So can you start developing the user interface before the APIs are ready? And typically that's one of those, well, we really don't like to do that. But at the end of the day, we say, yes, we can do that. Instead of interacting with a live API that's giving us live data, we will mock up what that looks like. And usually that's the service team. They'll create just a dummy implementation, something that returns data in the shape that they expect the API will return data. Okay, good. So we're dealing with this dummy data, and we can go ahead and make progress on the user interface as the service is working in parallel. And that's a good way to fast track when these things happen. But guess what? Many times that shape that we agreed to, well, that ends up changing over time. The service people say, yeah, we didn't realize that's actually going to be a capital A, not a lowercase a in the word assembly, or something like that. Or we realized that these properties where we had just one, we actually need to have multiple and need to have you look them up, or something like that. So that's a good example where we can parallelize, but there is risk. Because as a front-end engineer, I'm saying, okay, I was expecting to deal with a known complete API, but now I'm working with an API that's still changing, and that's going to cause me rework. So total amount of effort will increase. However, we do have an opportunity to still get the project done either on time or at least minimize the lateness, even with that additional work. Now, another option we have in Scrum is that we don't have titles in Scrum. Scrum is kind of big on the democracy of knowledge. And so the idea is that if our quality department is in a constraint, we can take some developers and have them work in quality. Or if the APIs are falling behind and on the user experience side, on the mobile app side, we don't have much to do, but you know what? There's Jennifer who's really good, not only at writing maybe an Android app, but also Jennifer knows how to write APIs really well. Can I lend you Jennifer? So there are ways that we can reallocate that are specific to Scrum, and that's somewhat expected. It's expected that we don't have titles, we don't have egos, and we're just willing to jump in and help out. How often do I see it happen in reality? Not as often as I'd like, but it is an opportunity that we have in Scrum. So let's take a look at that last animation where we were looking at resource leveling. And now this time let's consider resource compression. So still same constraints as before. 3 developers working in parallel, 1 quality engineer, 2 days to test per feature completed, and 5 days of regression. So, okay, Kaz Dolowitz starts with activity A, and you can kind of see elapsed time down here on this lower bar where we say, okay, we're now at day 3, activity A is complete, and so now Kaz says, okay, well, it's ready for QE. QE is available, not working on anything else, so we're going to pass that off to QE. Now days keep going. Kaz picks up activity D to start working on. Meanwhile, I'm down here in this bottom lane, and I'm about finished with activity C, and that has QE. Okay, well, looks like QE is busy right now, but so is everybody else. Kaz is on D, Pamela's on B. I just finished up C, and I can't test my own work by definition. I'll just put this in the queue for QE. They'll be able to get to it when they're available. Okay, time keeps marching forward. Now it's the end of day 5, and Pamela's finished with task B. So Pamela says, okay, this is going to take 2 days to check. Okay, quality is already behind, but hey, look, Brandon's not doing anything. And stand-up meeting, we go through our posts and our blockers, and we say that quality has a bit of a queue. I say I'm looking for something to do. Pamela says, okay, well, you're familiar with QE's guidelines and processes. Can you take on task B? And I say, yeah, I sure can. So now I'm testing task B. Time marches forward. Now Kaz is finished with task D, and it looks like we still have some potential overlap here. So, but Pamela's available. So we say, okay, Pamela, can you work on QAing task D? Pamela says yes. And there we go. And now it's time for regression. Now I said regression 5 days here. I said 6. Close enough, either way. Regression. How do we handle regression? Well, before we entrusted our QE department to do that, but you know what? Maybe instead of one big block, we can split it up into 3 different units, 2 days each. And then just as we did before, we can allocate regression to whoever's available. And then as soon as the developers finish with their regression tasks or their development task, they move to a new epic. What's interesting here is look at our finish date. Our finish date here did not move any later. If anything, we could actually finish a bit earlier by using the schedule compression. But the consequence is we also weren't able to free up our developers to move to a new epic as soon as we did when we did resource leveling, because our developers are now doing quality tasks. Okay. Maybe that's good, maybe not good. We do tend to think of people having specialties and that you want people plugged into the right role. So generally software developers should be developing software and quality analysts should be checking it. So this is a case where I say, let's plan that. Let's plan that software developers are developing software and quality is doing quality checks. But if we find ourselves in a bit of a pinch, let's not be afraid to use these Scrum rules of we can all wear multiple hats and reallocate people as needed, or anything else that we can do, maybe borrow some quality analysts from another team, anything else we can do to still deliver on time. So that's a look at resource compression and resource leveling. I hope you found this video helpful. I look forward to seeing you in the next one. Thank you.